Okay, hello everyone. Welcome back to Learn Orlen. Today we'll be taking on two-sum 2. It's essentially just two-sum, but our input array is sorted. As always, feel free to email me at learnorlen@gmail.com or DM me on any socials for more one-on-one tutoring. So let's begin. Given a one-indexed array of integers called numbers that is already sorted in non-decreasing order, or essentially ascending order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index 1 and numbers at index 2, where 1 is less than equal. Okay. Return the indices of the two numbers index 1 and index 2 added by 1 as an integer array index 1, index 2 of length 2. The tests are generated such that there's exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. So medium problem with some good constraints, but overall very simple if you know the approach. So looking at this, we see index 1 and 2, or 0 and 1, is equal to the target 9. Okay, we'll always have, there's exactly one solution. Okay, so let's go over the logic. We have one solution, and it is in ascending order. So we will be using the two-pointer technique. In our case, we will have one pointer at, we will call it left. It'll be at the very front, and another pointer called right. That'll be at the very end. And we will add together um, L and R, or left and right, and see if it equals our target. If it is equal to our target, then we return our indices plus 1. If not, then we check, is our target greater than 9 or less than 9? Or sorry, is our pointers add up to greater than the target or less than target? 2 plus 15 will be equal to 17, which is greater. So we need to decrement the R pointer. Now to 11, decrement to 7, 9. Here, 2 and 4 equal, return. Let's say the target was, let's say the target was 26. 15 and 2 would be equal to 17. We would need to increment L to keep getting closer to our target. So first I'm going to declare our three variables, int L, which would be equal to 0, and R, which will be equal to numbers.size minus 1, or the very end of our vector, and as well a vector of ints. Oh. That will have a size of 2. Now, all we have to do is we have to run a for loop now, but it's not a simple for index I. We are going to use a while loop. And with a two-pointer approach, you typically do while L is less than R. Or, so we can see this works because once they get near each other, then we can't go anymore. But we will have found our answer by then. If numbers L is equal to numbers R, oops, if we have found, for example, down here, my apologies, is equal to target. For example, 2 plus 4 is equal to target. Then result at 0 would be equal to numbers L plus 1. Sorry, not numbers at L, but just L plus 1, because we return our index added by 1. There we go. If numbers L plus numbers R is greater than target, what do you guys think should happen? Remember, we said numbers L and numbers R is greater than the target, then we would need to decrement to get closer. So we'll do R minus minus. All that is simply left is numbers L plus numbers R is less than the target, in which case we would need to increment L to get closer to our target. Then eventually these will be right next to each other. The while loop will end. All we have to do is simply return result. We could also um, break out of our loop slightly quicker, but it shouldn't take too long since we do satisfy the extra. We do have the most optimal solution. Here, let us run. There we go. Runtime 0 ms. We'll see most optimal solution. There we go. Perfect. O of n divided by 2, which is still O of n. Again, thank you for watching. Feel free to email me at learnorland@gmail.com for more tutoring help. Thank you.